The first two numbers are 1 and 10. And they both have locks on them. So these locks represent information that you should just have locked away. If you don't have that information locked away, if you don't know how to multiply 1 and how to multiply by 10, then you probably shouldn't start teaching multiplication. Now, it would be easy to breeze over multiplying by 10. Just whack a 0 on the end of any single digit number and there's your answer. And that seems like it's a good idea, but it's not. For a kid to really understand how to multiply by 10, they need to be able to do that with any number. So I'll write some numbers down here. If your children or students can multiply by those numbers and name the number that is the result of that, then great. They know their 10 times tables. But if they can only do it up to 100 or up to, whatever, then it's not that useful to them. This is such an important thing because it relates to our whole number system and place values. So getting it right is very, very important. You don't want kids making a mistake like someone at the bank did, telling me that our house loan was going to be this much and missing a 0. And, that could be a very costly mistake. So 1s and 10s, they're the first things. You need to have them locked away. The second symbol looks like this. Sort of looks like a fast forward sign. And you'll notice it's on the 2, it's on the 4, on the 8. I want to let you guess what that symbol might mean. If you've got one of them on the 2, 2 of them on the 4, 3 of them on the 8, you might be able to see a sort of pattern here. This represents doubling. So these symbols represent doubling. This means doubling twice. This means doubling 3 times. And the great thing about doubling is that if you know your 2s and you know how to double, you know your 4s, you know your 8s. So let's imagine we're doing 8 lots of 6. We don't know how to do that, but we do know how to double. So we start here with 1 lot of 6. We know that that's equal to 12. Whoops, that's 2 lots of 6. I've skipped ahead. 1 lot of 6 equal to 6. 2 lots of 6 equal to 12. 4 lots of 6. 4 is double 2. 24. 8 lots of 6. 48. And so using this idea of doubling each time, we can get to where we need to go. It's not the most efficient way, but it'll get us there. And that's okay. It's like when you get lost. You don't necessarily go the most efficient way home when you're lost because you don't know. So you find a road, like a main road that you know, and you find it. Once you've hit it, then you can take that back home. And that's what we should do when we're doing maths. We don't know where we are, find something familiar that you do know, and then work your way back using that. Now that's a nice one. I'm multiplying by 2. Each of these don't carry, but for a student to really understand doubling, they need to understand it with carrying. So if we do say 8 times 7, this will be a little bit different, more tricky, and we'll start here. So we'll start with 1 lot of 7, then do 2, then do 4, then do 8. So 1 lot of 7, easy. 2 lots of 7, again. 4 lots of 7, 28. Now doubling this. If your students can't do this, get them to break 28 into parts. We'll have 20 and we'll have 8. We'll double both of these and then we'll get to where we need to go again. So double 20 is 40, double 8 is 16. Add the 2 parts together and we get 56. So your students need to be able to do that. Double with carrying by splitting numbers apart or just, doing it in their head, keeping the carry in their head while they do it. So if they can do that, they know their 2s, their 4s, their 8s, but surprisingly, they will also know their 5s. I hear you ask, how are you going to know your 5s? By doubling. I don't know my 2.5 times tables. Well, guess what? Neither do I. Have a closer look. The symbol on the 5 is pointing in the opposite direction. If the symbol pointing this way represents doubling, this represents reverse doubling, or as normal people would like to call it, halving. So this symbol here, halving. What will we halve? Right. If we know our 10s, which are something that we should have had locked away, we can halve any of those to get 5 because 5 is half of 10. So that helps because a lot of kids can count by 5s till the cows come home, 5, 10, 15, 20. It becomes meaningless after a while. And what you want, so if they were answering something like 26 by 5, they'd have to count up 26 times 5, 10, 15, 20. It'd be a very slow process. So if they did this instead, 26 by 10, and they know their tens well enough to know that 26 becomes 260, and then they halve this answer, 5 lots of 26 is going to be 130. So that, understanding your tens really well, and then understanding how to halve or reverse double, that's really important. But that'll help you get to your fives and any type of five, because again, this information is not just to learn some set of numbers by rote, it's to transfer to any knowledge, because that makes what you understand useful if it can transfer to anywhere, in any situation, for any number. And so that's the importance of multiplication tables. We know them up to 10 and we teach them up to 10, and after that we can split other numbers up into things that we already know. So that's why we don't have to teach them up to, the 76 times tables, because there's no point. We can use prior information. So that's the fives. I'll be back shortly with the others.